we're going to take a test over exponent rules, simplifying radicals, and combining polynomials. So you can get your review signed, provided you also had it completed when you came into class today. You will be provided a formula chart. For our purposes on the review, I will be referring to the formula chart we put in our journal. So we will also be spiraling a couple of questions over systems of equations and also inequalities. So make sure that you've reviewed that information. So this first one, we had a question like this on our quiz. Simplify the following: a to the q over r, a to the r times a to the s. And we had talked about simply plugging in some numbers there so you could see what was happening. So if I had 5 here and I had 7 here, we know that we would need to do 5 plus 7 to get that 12 and then subtract that 20. So what I'm looking here is q minus the quantity of r plus s. You could also say q minus r minus s. That would be the same thing. So I simply want you to be able to depict that rule. Here you have the same thing, but you have actual numbers. So remember, when we are dividing, the rule is to subtract. And remember, the numerator goes first and then the denominator. So this is a squared b to the negative 3. Now, because it doesn't say no negative exponents, you can technically leave it like that. Another way you can write this, remember, a negative exponent is going to go into the denominator. So both of these are technically correct. So be aware that you need to be able to identify both. The area of a rectangle is 24x to the 7th, y to the 5th. Square units, the width is 6x to the 3rd, y squared. What is the length? So we know that area is length times width. So if I plugged in what we had, 6x. And then we're going to do this times length. We know that we need to divide this. And remember, when you divide, your coefficients are just that. You're going to do exactly what it says. So this is just 24 over 6. And then we would, because again, we're dividing like a number 2, we're going to have to subtract. So you should get the length is 4x to the 7th, y to the 3rd. Represent c to the 5th over c to the 12th in 3 different ways. Well, we could write c to the 5 minus 12. We can write c to the negative 7. We can write 1 over c to the 7. All of these are going to be equivalent. And then this one, don't overthink it. Remember, anything to the 0 power is 1. This is the only rule that is not on your formula chart. So because this is a 0, we would distribute this everywhere, which means everything is to the 0 power. So this whole thing simply equals 1. Write an equivalent expression. So all we're doing here is multiplying our coefficients. And because we're multiplying, the rule is to add our exponents, so 21, a to the 7, b to the 2nd. What is the volume of the cube? So we know that volume equals side to the 3rd power. So if I have this to the 3rd power, I can distribute it. So I get 3 to the 3rd. Remember, we're multiplying 2 times 3 and 1 times 3. So 3 to the 3rd, you can leave it like that, or you can simplify it to 27. A to the 6th, b to the 3rd. Simplify completely, so 72. So if you recall, we talked about finding your prime factorization. So we can do here, we can do 8 and 9. It doesn't matter what numbers you do. 2 times 4 and 2 times 2. And if you recall, we said you could rewrite this as 2 times 2 times 2 times 3 times 3. And remember, here is your root index of 2. We don't ever write that. So we are looking for groups of 2. They will go outside. So we have 2 times 3 on the square root of 2 we can multiply that to get 6 times the square root of 2. On the back, some more practice. Distribute first. So 1/4 times 8 over 1. This becomes a to the second over a to the third b, and then we can subtract. So 2 minus 3 over b to the first, and this is a -1, so that means we have 1 over a b. If this kind of confuses you a little bit, if you can get to here, you can write out a squared on the top, a cubed on the bottom, b, and you can see, in fact, that you are left with ab on the bottom. Write the radical expression equivalent to 4a over b, 4 to the a over b power. So remember, this becomes your root index, and everything else becomes your radicand. So the b root of 4 to the a power. Where we have a cubed root of 27. So if you recall, 27 is 3 and 9, which is 3 and 3. So I could rewrite this, the cubed root, 3 times 3 times 3. If I have 9 a's, most of you realize you can simply divide that to figure out how many you would have. So I have a group of 3's. I have 3 groups of a's and 2 groups of b. So everything is going outside. So 3 a to the third b squared. Sorry, the lights went out there for a minute. Simplify. So again, we're distributing. So we have a -3 to the third power, a to the 4 times 3, b to the -2 times 3. So remember, when you put this in the calculator, we had talked about negatives when you're using them. So you have got to put that -3 in parentheses before you put it to the third power. So 27, because remember, -3 to the third power, this one happens to be an odd power, so it'll work. But if this was an even power, it wouldn't work. So make sure you put your negatives in parentheses, -27, a to the 12th. This is b to the -6, so I'm going to actually put it down here. And then finally, collecting like terms. We did this the other day. So x squared with x squared. So 5 minus 3 is 2x squared. -6 and a -4 is a -10y. And if you have a negative, we said you had to distribute it. So this is, we have 7x squared minus 8, and this becomes a -3x squared plus 1. So 4x squared minus 7. Please let me know if you have any questions.